Science, science, science in pajamas. Alright, so welcome back. Today we're going to actually talk about the scientific method. So what it is, it's a set of steps that's used to answer a question in a scientific manner. What we mean by scientific manner is it uses defined steps that help us to objectively understand what is going on and form a reason for it. Now, depending on how you're learning it, which textbook and your teacher, you might not have 7 steps listed. You might have 4 steps listed. You might have 10 steps listed. It all goes back to exactly how the steps are being broken out. I've seen it, like I said, listed anywhere from 4 to 10 steps. It doesn't mean that the information is different. It just means that some books combine steps together and some books really just, separate everything out. So that's all that it's really talking about. The way I teach it with my kids is to use 7 steps. Again, whether you use 4, 5, 6, 7, 8, 9, 10 steps, it's all going to be pretty much the same process. It's just a matter of how many things are you combining under one step. So let us start with step 1. So what is step 1? Step 1 is you have to observe something. You have to observe something in the world around you. This towel. It's blue. I just made an observation. I observed something in the world around me. So, towel is blue. And that brings us to our next step, which is step 2. Now that I've observed something, I'm going to ask a question about it. So, ask a question. You can't ask a question about something in the world around you if you didn't observe and notice that thing prior to you asking a question. So, I observed that the towel is blue. So my question is going to be, why is it blue? All right. Great. Now we can move on to step 3, which is doing some research. All right, Ms. Komar can't spell research. Now, sometimes in school we won't necessarily do this or have kids do this step because the lesson provides them with the information. It provides them with a background knowledge as to the underlying what we're doing and why we're doing it. What I mean by that, we don't necessarily give the answer in the notes and all that and in the lessons, but we might talk about the information that can help kids form a better hypothesis, which is step 4. And we'll get to that in a moment. But first, we have to do some research. We have to learn about our topic. So I'm going to look into, all right, so this is made out of cotton. So I'm probably going to do some research and learn about cotton, the type of dyes that are used for it to make a different color. And I'm also going to do some research on light. Because maybe I remember that light has something to do with why we see colors. And again, the reason why research is so important is because of this next step. Now, a lot of kids know what this next step is. It's to form a hypothesis. Hypothesis. And like I said, most kids can actually define what a hypothesis is. It is an educated guess. And if you're going to make an educated guess, you have to have some foundational knowledge about your topic. You have to have some idea of the nature of what's going on. Doesn't mean you know exactly what's going on. That's why we're running the scientific method. But I can't figure out why this is blue if I know nothing about the fabric, the type of material used to give it color, and light, which helps me to see color. All right, so I've done my background research. I can now make my educated guess, my hypothesis. So based on my research, I'm going to say that my educated guess is that the tau is blue because the dye absorbs the blue wavelength of light. Now you'll notice I didn't necessarily put that in an if-then statement, which I know is very common for teachers to ask students. I put it in a because statement just because that's how I was taught. The tau is blue because the dye absorbs the blue wavelength. However, if you just flip-flop the front and ends of that sentence, you have your if-then statement. If the dye absorbs the blue wavelength, then the tau will appear blue. So it's pretty much the same thing. It's just a matter of order and all that. But yeah, so number 5. Now that we have our hypothesis, we are going to run some tests. We are going to experiment. So I'm going to set up some way that I can test my idea about why this appears blue. So I can, depending on the material I have handy here or at school, I can figure out exactly what kind of light and material this is. I can maybe get some cotton with exact same type of cotton but in different colors. And I can try and measure what wavelength of light is going through it. Well, what I mean by that is maybe when I set up my experiment, it's all up here. I just sometimes have trouble. All right, so maybe I can set up an experiment where I can actually measure wavelength of light. So I'm going to put this out in the sunlight because the sun gives off the full spectrum of visible light. And then I can measure which wavelengths are bouncing off, which will then also tell me if sunlight gives off this full spectrum of light, and I can measure that this is bouncing back, is being reflected off, and that tells me this part is being absorbed. So maybe I can find some way to measure that. Maybe I can, again, it all depends on the material you have gathered or the equipment and the different scientific apparatus you have available to you. So that might be one thing I do. Is there one set experiment to do? Usually not. I mean, sometimes in class, because we want to make sure we have certain materials, we'll say run this particular version of an experiment, or you have this material, come up with your own experiment. A lot of it is just because of available materials. All right, so I'm going to run my experiment. Next, I'm going to make observations during the experiment. And what that means is I'm going to collect data. So when I run my experiment, it should give me some form of data. However, I need to be able to observe that data. So whether it's by reading machinery or taking measurements or just doing observational studies, I need to collect that data in some way. And that's what the observations are. So let's say in my original experiment, I predicted, this would be the blue portion of the spectrum. This would be the red portion. So when I ran my experiment, this is what I expected to see based on my hypothesis that the blue would be absorbed, but the red would be reflected back. But maybe I collected these observations. So that's the full spectrum. And what I'm noticing is that in my data, it looks more like this, where once again, blue side of the spectrum, red side. And I'm noticing that this is what's being reflected, and that's what's being absorbed. So that's what the data tells me. Well, now that I've collected my data, I've made my observations based on the experiment, I've collected my data, I can now analyze it and use it to draw a conclusion. Puppy on the move. So, according to my data, my hypothesis was wrong. So that's part of your conclusion. Was your hypothesis correct? Or was it incorrect? My hypothesis was incorrect. I said that I thought the cloth was blue because the dye in it would actually absorb the blue wavelength. However, when I ran my experiments, I noticed that it was only the blue wavelength that was being reflected. Everything else was being absorbed. So my hypothesis was wrong. And guess what, kids? That's okay. It's okay to have a wrong hypothesis. It doesn't mean you did the experiment wrong. It doesn't mean you did any of this wrong. I mean, yeah, you might have had a wrong educated guess. But look at the last part of that. Educated guess. It's what you think might happen. It doesn't mean that you're going to get it right every time. In fact, a lot of times, scientists do learn more from mistakes and wrong hypotheses than they do from right ones. Because if you're right, great, woohoo, you're done. Yes, hi, good boy. Hi. But if you're wrong, then it allows you a chance for more exploration, more learning, deep diving into that material and finding out more about it. Like I said, that's just a guess. It doesn't necessarily tell you why if you're correct. But since my hypothesis was wrong, now I get to try and figure out, okay, why was it wrong? What was it about my assumptions of light being absorbed versus reflected that led to the wrong hypothesis? So it's okay if your conclusion shows that your hypothesis is wrong. There's absolutely nothing wrong with that. Nothing wrong with the wrong hypothesis. See what I did there? It's okay, though. That's not the point of science. The point of science is not to always be right. The point of science is to learn about the world around us, to gain knowledge, to understand what occurs in this huge, mysterious universe. And we're never going to have all the answers. And even when we think we have the right answer, as technology gets better, oftentimes we learn new things and we find out some of our previous thoughts and beliefs were wrong. And guess what? Science takes the new information, it takes those new facts, the new evidence, it incorporates it into itself, and then it modifies what it tells us. That's why Pluto went from being a planet to not being a planet to being a dwarf planet and possibly to being a regular planet again. Because as technology gets better, we learn more. As we learn more, we can now change our understanding of the world around us. Science doesn't back down from facts. It welcomes it. It welcomes new information that challenges it. It says, all right, we were wrong about this for this reason. That's fine. Let's incorporate into that information into ourselves and grow from it. You know, several hundred years ago, science was convinced that everything revolved around the earth. We know that's not true. We know that the only thing that revolves around the earth is the moon. Earth, revolves around the sun. All the planets in our solar system revolves around the sun. And all the solar systems in our galaxy revolve around the middle of the galaxy, and everything in our galaxy is moving away from the center of the universe. We know that now. We didn't know that back then. But once we got the information, once we got the knowledge, the facts, the evidence, we changed how we view the world and its position in the universe. And that's what science is about. All right, so I hope that helps you. Hope you learn a lot of good information about the scientific method. In our next video to come, we will talk about types of variables and things like that in an experiment. So, hope to see you then. All right, you guys, stay safe, stay healthy, and bye-bye.